Good morning students, myself Badi Alekhya, Assistant Professor, Artificial Intelligence and Machine Learning Department, RMD Engineering College. So today we are going to discuss the first topic of our third unit, proportional logic. It's a very important terminology. So when we are going to write any sentences or we are making to understand the sentences designed by the human to the machine, we need some logic representation to understandable to the machine. So under the type of logical representation, proportional logic is one of the type. So let us see how we are going to implement proportional logics with some of the examples and what are the drawbacks of proportional logics and how it is going to be overcome in the first order logics, and what is the difference between proportional logic and first order logic with examples. So let us move to the session. So first come to the definition of proportional logic. It's a simple form of logic. So in other words, we can also call it as Boolean logic. So what is Boolean logic? We can represent whether the given statement is either true or false. Either that means it's a declarative statement for representing any knowledge versus sentence by the represented by the human experts is could consider in the form of logical and mathematical form, and it is could be provided the results in a declarative form, either it has true or false. So some logical constants here we are using that where if the given statement is either true or false, or proportional symbols, atomic sentences, complex sentences is there. For wrapping parentheses we are using. So in the examples it will be cleared how we are using these symbols and connectivities in our logical representations. So you are aware of that this symbol will represent and, that is conjunction or distinction. So both will represent by using and, any one we represented by or, and then if then will be represented by implication. It's a conditional. So if and only if these two things will, if more than thing conditional we have to consider na, so it will be represented by implications, and if it is it's not, that means it is represented by negation. So literally is atomic sentences or negated atomic sentences. Generally negation will be implemented for the atomic sentences. See here, I am going to declare the variable it is hot, it is represented, I am assigning the predicate P. It is humid, it is assigned to the predicate Q. It is raining, it is assigned to the predicate R. So now I am going to write some complex sentences by using proportional logic. Now it is hot, it is humid, then it is raining. So if these two conditions will be satisfied, then the conclusion it is raining. So how you are going to represent these sentences in the form of proportional logic now? So it is hot and it is humid, then it is raining. So the P will represent hot and Q will represent humid. If these two conditions will happen, then the result is raining. So in this way we are going to represent the proportional logic sentences. So Q implies P also means if it is humid then it is hot. So this is also one type of representation of proportional logic. So here hot is it is hot, humid is it is humid, raining is it is raining. So these are some of the predicates which will be useful in designing of our proportional logics. I think so it's clear for you people. I can move to the next example. So what is this and implies are, these are all logical connectivities which is used in our proportional logic. See already we discussed this previous example. This P represent hot, Q represent humid, it is red, it is a well defined. See, user define the semantics of a proportional symbol. That means here the symbol P, this P symbol will have a meaning of hot, it is hot. This Q symbol it has a meaning of it is humid. That is semantics is nothing but the meaning for the given sentence. So already we studied is connectivity. S is a sentence. So for that negation you have applied na, so opposite sentence. So if two sentences are there na, which way we are going to connect the two symbols, the two sentences, sorry, by using logical connectivities. So or, and, implies, and then double implies, these are all some of the logical connectivities. In technique, in words we have to say na, this will represent if then statement, this double implication will represent if and only if statements. So these are same things. Atomics, your proportional logic is a BNF grammar form. So your sentence, either it is a simple sentence or it is a complex sentence. It is a simple sentence, you can decide the result by using true or false, or complex sentences by using some logical connectivities. We are going to provide the conclusions. What are the logical connectivities? You know, negation, so and conjunction or distinction. Implies will represent arrow mark, if then, and equal double implies will represent equivalence or if and only if. Thus this is the way of represent what we studied in the previous slide. What are the logical connectivities and what is proportional logic? They are going to represent in the form of BNF grammar. So what are the logical connectivities? So and or negation, implies and double implies. So some terminologies, that semantics is meaning, interpretation, truth values. So possibly whatever the facts we are going to represent, that it should be stored and maintained under knowledge base. If under the knowledge base it is stored as one statement, if I tell that the rose is red, it is stored in a knowledge base. If I future, if I want to retrieve and ask the query to the machine, it will be, I will ask a question whether the rose is red. Now the system will reply with answer red, because the knowledge base stored the rose is red. If I type a question whether the rose is yellow, now it will represent the output as false. Why? I stored the I stored the fact the red rose is red, but it's not yellow. At that time, the under the if I ask a query to the machine, it will be represent as false. So if I initially I tell that the proportional logic is a Boolean logic, it can represent either in the form of true or false. Some of the more terminologies, so valid sentence, not is that is true statements, contradiction is false statements, implication statements. So you already know the two tables what we studied earlier in our previous year itself. You know what is the meaning of and. So both conditions true, otherwise it's a false, are conditions. And then if the condition is true, then only the statement will be executed. If statement is true, if the negation is statement is false. So here we represent some of the two tables for all logical connectivities, negation and or implies and double implies. So logical inference, create a new logical sentence that are perfectly predicated calculus under the knowledge base. So when we says the inference rules is shown, the knowledge base what we retrieved does not create any new contradiction, then we can say that the inference rule is sound. When we can say the inference rule is completed, inference rules is nothing but what are the facts we stored, whether it is retrieved in a correct manner or not, will be take care by using inference rules or inference engine. When we take it as a complete, it produce every expressions to complete your search process. So modus ponens and introduction. Modus ponens is represented in the form of A3. That means if A and A and B A common, so that is representing the conclusion B. So this is the sum of the representations of modus ponens: introduction, elimination, negation and resolution. So this will be useful for you at the end of this either that is means if it is in the form of A plus B, we have to apply the negation of that, and we have to see is if you are giving these things, the contradicting terms will, resolution is nothing but it will be useful at your fourth unit. If A or B is there, negation B or C is there, the contradicting terms will be cancelled. So the contradicting terms will be cancelled. Now what is your conclusion? A or C. For example, A or B, I take one sentence, sir, in the form of A, I like apples or I like bananas. Here I don't like bananas, but I like apples. So that means I love oranges, like that. If I things is that I like bananas, I don't like bananas will be cancelled, and it will be representing the contradicting term A or C. So in resolution we are going to applying this formula. Should be remember that it will be useful when we are solving the resolution problems under your fourth unit. This rule is very important. These are the sound of some products through true, that implications, that implication truth table we have to consider. proving things that we studied in the first example. How we are going to humid, it is humid. If it is humid, it is hot. Hot. How we are going to frame it as a sentence, and how we are going to join by using some logical connectivities, and how we are going to that conclusion we are call it as modus ponens. So okay, the proving the things we call it as modus ponens. So if your case it is a humid, it is hot, it is hot, it is hot and humid, it is raining. The our conclusion is if it is hot and humid, surely it is raining. Our conclusion will be reached by using this modus ponens technique. Horn sentences. So it's also one of the terminologies used under propositional logic. So its implication will be equal to if a negation the other name for horn class we also called as class form or CNF representation. So this formula also will be useful at the end of your fourth unit problems. So if a representation is in the form of P implies Q, then you can apply CNF form or horn class form, that P will be converted into negation and implies will be converted into R. So this type of form we call it as class form or CNF representation. These also the very important notation which will be helpful to solve the problems of your next unit. So listen carefully. If it is in the form of A implies B, it's going to convert the A into negation A and implies into R and then represented Q. This is the notation which is represented for horn clause for solving some predicate logics. So already we discussed that soundness and completeness in the previous slides in knowledge based. So what is the weakness? How we can say propositional logic is a weak language? No, it does not represent. It represents simple atomic sentences, complex sentences, but it not provide the relations. That our relations will be represented by using first order logic for expressing things. All loves ice cream. Some like tamarind rice. That means for representing or for representing something is not going to be covered under the propositional logics. This type of logics will be implemented by using first order logic. If you are representing, see here this the symbol which is used to representing all is all, everything will be represented by using the reverse with slash line, and there is a white, there is means for representing something will be represented by reversing. So these two we call it as quantifiers. So for all representing quantifiers we call it as universal quantifiers. There exists represented quantifiers or something represented quantifiers, we call it as existential quantifiers. I repeat it again. These representing all will be represented by this symbol, and representing something will be represented by this symbol. The name of this symbol is universal quantifiers. The name of this something representing symbol we are called it as existential quantifiers. So Vamper's world problem is there. So I will tell the condition is exercise for you people to complete how to apply the propositional logic for this problem. It's a very easy task, and I explain the conditions to you people. Based on conditions, you have to provide the solution in the next session. See, this is the grid. Clearly reason what are the things I have to provide in the problem. So I have agent, breach, glitter, okay, pit, stench, visited, vampus. So agent is our who is doing the actions. I will tell conditions first. Based on the condition, you have to apply your propositional logic theorem under this problem. So first agent is presented at one grid. If the agent is moves forward one step, if he feels a breeze, my condition, listen it carefully. If I feel a breeze, there is a pit in the adjacent nodes. So first condition is if the agent moves to the moves a step forward in that particular grid, if he feels breeze, and then there is a chance of pit in the adjacent nodes. So and what is the next condition? If the agent visits some node, if there is a stench, that means bad smell, there is a chance of vampus in the adjacent nodes. Vampus is a devil. So if there is a stench, if the agent visited some particular node, in that particular node if you feel a stench smell, there is a chance of there is a chance of presenting vampus in the adjacent node. So note the second conditions. The agent will start from 1, 1 grid. If he moves forwards and if he feels breeze, If he moved forward, if he feels breeze, there is a pit in the adjacent nodes. If he move forwards, if he feels stench, there is a there is a chance of vampus in the adjacent nodes. If he visited a node, visited a grid, and if he feels a glitter, glitter means there is a chance of gold in the adjacent node. So the I node now I goal noted the goal. If he visited after visiting the things, he has to catch the gold and leave the environment safely. For that, what type of proportional logics you have to apply and implement it? Try it as an assignment. Conditions will be cleared, I think so. If you visited, if a visitor grid has bench breeze, there is a bit in the adjacent nodes, there may be a chance. If the visitor node has stench, there is a chance of vampus in the adjacent nodes. If the visitor nodes have a glitter, there is a chance of gold present in the adjacent node. Following these conditions and apply the proportional logic rules and submit it as an assignment. We will discuss the solutions